Imagine that I am a social scientist looking for groups in this simplified version of the social networks of merchants of the 17th century. Fekete clustering works with nodding diagrams, but I will demonstrate it using Paolis. All the people are listed here, and each vertical line represents a contract between two or more people. Using existing clustering tools, I will randomly choose one algorithm in a long list of mysterious names, like Louvain. I will then pick parameters I do not quite understand, run the clustering, and look at the results. But how good are those 6 clusters? Typically, I scan the names to see how it matches what I know, or what we call prior knowledge. For example, I know that Marie Boucher and Jean Masson-Lesnay are friends, so it makes sense to find them in the same blue cluster. However, I think that Hubert Antome and Marguerite Antome should be in another group together. We see here that it is not the case. I might try again with another algorithm, but would really prefer a more systematic method. With Fekete clustering, I first describe my prior knowledge by creating partial groups. I create a new group, add Marie Boucher and Jean Masson-Lesnay, and call it Group A. I then put Hubert and Marguerite Antome in another group, that we call Group B, in red. When I start the clustering, all the algorithms implemented by the system are run automatically. They are ranked by how well they match my prior knowledge. The top 6 algorithms have a perfect match. Both persons of the prior knowledge group A are found in the same cluster, and the 2 persons of the second prior knowledge group are together as well in another cluster. 2 algorithms have a partial match, and those algorithms did not match anything at all. The other people in each matched cluster are represented with these white circles and a number. The other clusters found by the algorithms are represented here on the right. I will start by looking at one of the most promising algorithms. I click on Louvain time. I see 3 groups, A, B, and others. The people from my prior knowledge are easy to spot. I can click on Others to see the other clusters in detail. But I would prefer to see how the top algorithms compare. The algorithms which gave a perfect match are selected by default. I select the 7 algorithms and click the Compare button. The 7 algorithms are listed on top, along with the prior knowledge. By default, the first algorithm is used to group the persons. I can see that in the group B, there is a lot of agreement. For many people, all 7 algorithms agree. For others, only 3. On the other hand, the consensus is less clear for the blue group. Only 2 algorithms think that Jacques Souchet is in this blue group. One algorithm even put him in the red group. At this point, I will go look at the network or read other sources to decide what is best, and come back to enter my decision. Using the consensus slider, I can select everyone with at least 4 diamonds the same color. They appear as circles in the consolidated knowledge column on the right. I then validate the suggestions by clicking or dragging on the circles. They turn into squares and will not change again. For the other persons, depending on what I learn from the graph or other documents, I can copy the suggestion of an algorithm. For example, I believe that these people are part of the red group, along with Jacques Souchet. Or I can leave them undecided. I am now done expanding and validating the prior knowledge clusters. Now, let's look at the other clusters. Clicking on Others splits the other people by the clusters found by the currently selected algorithm. I can compare how the different algorithms do that. The clusters found are ordered by consensus. If I hover over a proposed extra cluster, the similar clusters found by other algorithms are shown in green. If I agree with the suggested cluster, I validate it by clicking on its name. I then can rename it. I then can consolidate this new group. I can repeat with other clusters, but I can leave things undecided as well. Now, I have a consensual and satisfactory partition that considered my prior knowledge.